Thanks for joining me. This lecture topic is entitled JMeter Database Testing. Since JMeter is Java-based, it is expected that it would be, by default, use Jdbc for connecting to a database for testing. In JMeter, there are two elements that are important to define database connectivity and database requests. To configure the connectivity, JMeter provides a Jdbc connection configuration element. To support dialogue over the database connection, JMeter provides a Jdbc request element. I had to make some decisions and do some preparation before I created a new JMeter script that would test database access. I chose to use the MySQL because of cost. MySQL has an open source, no-cost option, and it has evolved into a free tool that has both a good administration tool and database client functionality. So I located it on the internet and downloaded its installation software for the database manager, administration, workbench, and MySQL connector/J, JDBC jar support for JMeter. The MySQL connector/J JDBC jar file must be copied and pasted into the JMeter lib/ext folder. If the JMeter IDE is active during the MySQL install, it must be restarted to point to the new jar file. An 1146 error will occur if there is a problem with accessing the jar file. Now, this is for MySQL. If you decide to choose some other database management system, you might encounter some other type of error. For my next decision, I chose to locate an existing MySQL database on the internet that would allow a simple import or load file to store into the database manager. Fortunately, I found a classic car schema that was useful. The database is available at this site. It is easy to load using the client tool once the database management system is running. With the connector and MySQL in place, I was ready to turn to JMeter and create the JDBC script. Join me in the short lab session. I have the script open in JMeter, and it is using the JDBC test plan that's in the templates. And so here it is. We have a thread group. We have a JDBC connection configuration element, JDBC request, and our normal debug. I'm not using this processor. It's just there. Thought I might need it, but nope. And we have a view results tree, an aggregate report. All right, let's go in a little more detail. Let's start with the connection. What we need for connectivity. Starting at the top here, we have a variable name that's JDBC config. It could be any name, whatever you want. It comes with this name in the template, so I left it that way. And it is used not only in the configuration, but over here in the request, you'll see that same name. So whatever you put in one, you put it in the other. Go back to configuration. We have some other settings here for the pool configuration. The only thing I changed was changing it from 10 to 100 open connections. And come down, everything else, leave it as is for now. And the next thing that we need to put in is this information here. I'll highlight it for the moment. We have JDBC : MySQL / localhost 3306 is the port that we'll dialog on for JDBC, and finally / classic models, which is the schema name of the database. And then on the next line is the JDBC driver class. That's what will point to the jar file, but it's a name that's standard. There are other names that you could specify for other drivers that you might use. This one is com.mysql.jdbc.driver. And that's all you need there. Then whatever user, you might be using the username, the root username, or you may have defined some other name and specify that user and whatever associated password. And so those are your user credentials to get into the database to access and specify a query. Now, speaking of query, let's flip over to the JDBC request, and here's where the query is placed. Simple query, could be a complex one. Select a product code, which is a field on a table called products. That's simple. Nothing else to specify. Near the bottom, we have two more designations that are needed. One called variable names, and that came with the template, col1. I left it that way. You'll see what it does with that. And another one, I gave it this name, result data. Call it whatever you want. These are just variable names that are going to be used to store data. And we've talked about the debug sample, the reason I put it there, or because of these variables that we want to see in the output. And the view results tree is here. We're going to see the results. I actually ran it, so we're going to see the results almost immediately. And then the aggregate report, let's start there. We can see that the JDB request took roughly 2 seconds, and that's it. To get the data that it got, it took 2 seconds to do so. Maybe that's a good thing, maybe it's not. I'm not sure at this point. Running on my machine, I'd say that's probably okay. Now, let's look at output. So here we have JDBC request, and here we have a select statement that you saw in the JDBC request. That's what was sent, and here's what returned. Product code and a list of product codes. And you could scroll down and see that there were somewhere around 100, I believe it was. 100, 110. Okay, then if we look at what else I wanted to, the debug sampler, we see that information again. We see the col1, and notice that it changed the number at the end, so you could see, well, what was that 110th row? And here it is, this value, S50_1341. So you can actually confirm, if you'd like, all of them are there. And then we had that other variable that was called result data. And you can see it puts it all together into a table in that one variable. So we have product code followed by the value and nothing but keyword value pairs all the way down. So that's another way to view it. I put variables in both of those positions so we could see the difference. One shows it in a single variable and the other shows it as a table. That's all there is to it. It's fairly simple, straightforward. If you go back to the Jdbc request, you can see that you could enter multiple queries. That would be acceptable. The part that you want to be concerned about mostly is being able to look at what the response time is, being able to tell what performance occurred, and look over at the throughput, especially for database activity, wanting to know this kind of information. You also have the ability to look at, with MySQL, it has performance monitoring capability, and so you can look at it real time as well as after the test is completed. So it's useful as well. I didn't take the time to show it, but it looks decent. And one more thing about that, instead of putting multiple queries in the same request, you could put them in separate requests, same thread group or different thread groups. Our thread group is really simple. We're just using the original one to say one thread, ramp up at this amount of time, and loop one time. If you wanted, you could take that same query and run it multiple times, determine whether there's good buffering going on. So it depends on what you're looking to test or to confirm that looks good, or whether it's something that might not be so good. But you have different ways. You have flexibility in how you construct your test, your query, and your script. Thank you for your time. My time has ended for this session. I thank you for yours.